Hello students, in this video I'll be teaching how you can use the simple technique of triangle law of vector addition in calculating the time period and range of a horizontal projectile. So here you can see there is a particle which is being projected with a speed u at an angle theta with the horizontal. You can trace the path like this and this particle will follow this curved path and fall onto the ground right here. So the range of the projectile is the distance from the point of projection to the point where it will hit the ground, and the time of flight of this particular projectile is the time it takes to fall back onto the ground. Now the given information here is you've been given the speed, you've been given the angle of projection, also the gravitational acceleration g. Now the basic idea is we know that this particular particle is having a uniform acceleration, that is a constant acceleration of g. So for constant accelerated motion, you could use the second equation of motion, which is s is equal to ut plus half times a into t square, right? Now here, what is s? S is the displacement, u is the initial velocity, t is the time, and a is the acceleration of the particle. Now in this situation, s is actually the range of the particle. So I'll just write it as r vector is equal to, u is the same here. So I'll just write u times t plus half into the acceleration of the particle is g. So it would be g into t square. Now I will slightly rearrange this formula, this particular equation as follows: r equals t into u vector plus t square by 2 into g vector. Now here you can see that we have two vectors, the sum of two vectors giving you a third vector, right? So let's just draw the vector triangle here. So you have vector number 1, vector number 2, and the sum of these two vectors is the vector number 3. So vector number 1. So vector number 1 would be u vector scaled by the time t. Now this particular time t should be the time of flight capital T. So let me just change this. I could write it as capital T and this one also as capital T, right? So this is capital T and this is also capital T. Now let's draw the vector triangle. So the first vector is vector u scaled by t, that is you are just multiplying this vector u with a scalar quantity t. So the direction of the vector would also be this one. So this is the vector t times u vector. All right. Next is the vector g, which is scaled by a number t square over 2. Now the direction of g is vertically downwards. So the vector would be t squared by 2 times g vector. And finally, the sum of these two vectors has to be horizontal, that is given by this physical condition. So the vector would look like this. This is our vector r. Alright, so this is our vector r. Now if you look at the simple geometry here, you could see that this particular angle is theta, because this is the angle made by u with the horizontal, and in this triangle it is the angle made by ut with the vector r, which is also horizontal. So if this angle is theta and this r is horizontal and this particular vector is vertical, so this angle has to be 90 degrees. So this angle would be 90 minus theta. Now using this particular triangle, all you need to do is, in this triangle, all you need to do is use the Sine Law of Triangles. So if I use the Sine Law of Triangles, you could see that this side ut divided by sine of the opposite angle, that is sine 90, is equal to this side t squared by 2 into G divided by sine of the opposite angle, which is sine theta, is equal to R divided by sine of the opposite angle, which is sine of 90 minus theta. Okay. Now, if you simplify this equation, you would get the following. You will get ut by 1 is equal to gt square by 2 sine theta is equal to r by cos theta. Okay. Now, if you look at the first two equations, if you look at this combination, if I take that combination, ut is equal to gt squared by 2 sine theta, I get t is equal to 2u sine theta by g. Alright, so that is the answer for the time of flight of the projectile motion. Okay, and once I have this time of flight, all I need to do is just look at these two, this particular equation, that is u into t is equal to r by cos theta. That would give me r is equal to ut cos theta. Now just plug in the value of t here, you would get 2u square sine theta cos theta by g. Alright, and simplifying the same, you would get r is equal to u square sine 2 theta by g. That is your range of the projectile, and this right here is the time period of the projectile. So here you can see that I haven't taken any components of any of the vectors. All I have done is draw the vector triangles of three vectors u, g and r.